All right, so we're starting chapter 9, and the first thing we're going to discuss tonight are compound inequalities. What's your name? I'm sorry. Okay. All right, so first of all, we need to discuss, that's an I too, inequality, I-E-S. Okay, we need to discuss what an inequality is. So an inequality is any algebraic expression that has a less than or equal to, a greater than or equal to, or a greater than in it. Okay? A compound inequality is a lot like a compound sentence in that it's two or more inequalities united, okay, in one problem, so to speak. Union, there are two types of compound inequalities. We have unions and we have intersections. Now, I like to go to the literal meaning of the word union and the literal meaning of the word intersection before I talk about what it means in mathematics. So when I think of the word union, I think about a marriage. You know, you'll say, they go to a wedding and they'll say, we're here to celebrate the union of blah, you know, two people, whatever, okay? When two people marry or union, they don't just take the things that they have in common with them to the marriage. They take everything, all the qualities that this person has and all the qualities that this person has, and they become married. They union, okay? Unite is the word, but we're going to use the word union because we're going to try to relate it to this, okay? So all of both people go into the marriage, correct? If you only took what you had in common, there would be no divorces. Correct? Probably so. Yes, that joke usually goes over well with students. I'm sorry, it's not working in this class. Okay? Whereas if you think about the word intersection, I think about two roads where they intersect each other. It's where they cross. When two roads intersect each other, if you stood right in the middle of it, don't do that. Do not try this at home. But if you stood right in the middle of the intersection, you couldn't say that you were on one road or the other. You would have to say you were on both roads because you're standing on the ground that they have in common. Okay? So an intersection is what two things have in common, and a union is all of both of them. Okay? So that's just my own little words that I use. So I'm going to write that on here. Okay? If you have two sets, set A and set B, the symbol for union is a capital U. It's not really a U, it's kind of a wide U-looking thing. So if I said, what is A union B? It would be the elements in A or B or both. So it's everything, okay? This would be everything in A, everything in B, everything that they both share in common. If I ask for the intersection of A and B, the symbol looks like this. It's the reverse of that. And it's only the elements that are in A and B together. So it would be that middle part there where they overlap each other. Okay? If I gave you a set, let me give you 3 sets. No, let me just give you 2 sets. So I'm going to give you set A. So we're going into an example with numbers in it. Set A is 2, 4, 6, 8, 10. Contains the elements 2, 4, 6, 8, 10. Set B contains the elements 3, 6, 9, and 12. If I asked you for A union B, the union of the 2 sets is the marriage of them. So it's all of both sets, okay? So you're going to take every element that A has and every element that B has, and you're going to put them all into one set. If there's a repeated element, don't write it twice, okay? So 2, and it really doesn't matter what order you put them in at all. Generally speaking, you'll see least to greatest. So 2, 3, 4, 6, I see 6 in both of them. 8, 9, 10, and 12. And those are commas. My pen is not, it's doing something funny tonight. If I asked you for A intersect B, that means I'm only looking for what they have in common. What elements or element do they have in common? Or do they both have? The only one they have in common is 6. So the intersection of them is 6. Any questions? Okay? So we're going to move on to inequalities and unions and intersections of inequalities. The first one is going to be given that B, so given that B equals the set of all x such that x is less than or equal to 4, and that C is the set of all x such that x is less than 0. Let's find B intersect C. Now, with these being number lines and not actual just single elements of numbers, you're going to want to draw these number lines out, okay? And it's usually best to put them one over the other one so you can see sort of if they have any overlapping numbers or anything. So I'm going to graph this one first on a number line. This will be B. X is less than or equal to 4. So here's 0, here's 4. Less than or equal to 4 would be a closed circle on 4 shaded to the left. C would be a closed circle or an open circle on 0. What would it be? Open circle on 0, and it's also shaded which way? Less than is to the left, right? Now, you are looking for their intersection. So I'm looking for what they have what? Intersection. What they have in common. Okay? So this one starts at positive 4 and goes left. This one starts at 0 and goes left. What do they have in common? Think about the numbers. Do they have 4 in common? They're shaded regions. No. They don't have anything between 0 and 4 in common, do they? But they have everything from 0 to negative infinity in common. So what we have to do now is just simply decide, do we put an open circle or a closed circle on 0? Well, that depends on if they have it in common or not. This graph contains 0 because the graph of the line went over 0. This graph does not contain 0. So they do not have 0 in common, do they? So you'll put an open circle on 0 and shade it to the left. What if I asked you to find their union? Always go back to the definition. The union of them is the marriage of them. So all of both of them must be contained on my answer graph. Okay? This one starts at 4 and goes to negative infinity. This one starts at 0 and goes to negative infinity. They are marrying each other. They are taking all of their numbers with them. So when I put them together, I slide them together. What is graphed? Everything from 4 to the left. That's the marriage of them. You know, it's a great question. Everything I'm seeing in your book has number lines, so I don't know. I think they'll probably give you a number line. Who's done this already? Did they give you number lines? Everything has a number line, so that's there to help you visualize it. And even if it's not, and that's the way you can see it best, then just do it. If I asked you to write this answer of this, you would say the set of all x such that x is less than or equal to 4, wouldn't you? Because your answer should match your answer number line. Okay? And this answer for the intersection would be the set of all x such that x is just less than 0. So those are my two answers given those two inequalities. Okay? Sometimes they're going to give you a compound inequality and ask you to solve it. Let me go over to this side right here. If the inequality contains the word and, let's go back up. I'm going to go back up in my notes. It'll just be easier for me. If the inequality contains the word and, it's an intersection inequality because you want this and that. You want what they both have. Okay? If the inequality contains the word or, it's a union. Now, all union or Yeah, all union inequalities will have the word or in them, okay? All intersection inequalities will not have the word and in them because they can be written like this. That's an example of an intersection inequality in which there's no and in it. This same inequality could also be stated as x is greater than -4 and x is less than 7. So these two things are the same thing. A union will always have the word or in it. Always. There is no other way to write a union inequality than with two, that has two, where you're uniting two inequalities. They must have the word or between them in order for it to be a union. So only one way to write this. X is less than 3 or x is greater than 7. Okay? Everybody got that? I can move back down. We good? I really try to bear down on this because this notation confuses students sometimes. Okay? They're good if they see the word and the word or, and they can remember or goes with union and goes with intersection. But when they see this, they're like, ooh, what does that mean? Well, it's all the numbers between -4 and 7, which is what they would have in common, what these two would have in common. Okay? All right, so let's go back down and work one. So this says solve the compound inequality. -4x is greater than 8 and -3 plus x is greater than -10. So because it has the word and in it, it means that I am looking for the intersection of these two. They should actually say solve and graph because that's really what they're wanting you to do, even though they didn't say it. Okay, so we're going to solve this inequality just like we solve all inequalities, the same way we solve equations. Whatever you do to one side, you do to the other. So I'm going to divide both sides by -4. Now, you do have to remember what you learned. When you divide an inequality by a negative, you must flip the inequality sign. And 8 divided by -4 is -2. You can bring down the word and. I thought I did. Lord help me. I said it, but I didn't do it. Thank you. Been a long day. There we go. So x is less than -2. And, so I brought down the word and. Here, I'm going to solve for x by undoing whatever's done. It has a -3 added to it, so I'm going to add a +3 to both sides of the inequality. And I will get x is greater than -10 plus 3 is -7. Trying to see if they want us to write our answers any certain way. So let's graph it. Here, let's put 0 here because we're all in negative land here. So -1, -2, -3, -4, -5, -6, and -7. So x is less than negative 2 would be shaded. So what I'm going to do is I'm going to graph them above the line. Less than negative 2 would be an open circle at negative 2, shaded to the left. Greater than negative 7 would be an open circle at negative 7, shaded to the right. Because it contains the word and, you are looking for what they have in common. So my answer graph is going to be the one I'm going to put on the actual line. What do these two graphs have in common? Everything that's between what? Negative 7 and negative 2. And this circle is open here. My marker went a little. This is an open circle, and that's an open circle. Okay, let's see. So everything that's between negative 7 and negative 2 is what they have in common. If you were to write this in the more condensed format, you always start from left to right, and you always put less than or equal to signs in there, depending on if the circles are closed or open. So least to greatest, less than signs in there. Okay? Okay, let's do one where it's written like this, and I need to solve it, just keeping it in that form. Okay? Because x is what? Because x is greater than negative 7. So if I read this from right to left, that would be negative 7 is less than x. Negative 7 is smaller than whatever x is. And x is smaller than whatever negative 2 is. Or whatever x is smaller than negative 2. Excuse me. You always want to read your inequalities with your variable first, okay? X is less than negative 2 and x is greater than negative 7. But if we want to write them in this format, you have to keep the sign pointing at the same thing it's pointing at. And you always put your variable in the middle, okay? And this is a good question that he's brought up, because it does escape some people when you switch it around. I used to give a worksheet that made students write in words how to read inequalities from left to right and right to left. So this, if I read this from right to left, from left to right, it would be x is greater than negative 7. But if I read it from right to left, it's negative 7 is less than x. Does it make sense? Okay. Are we clear? That is a prime source of confusion with inequalities. Just keep in mind, negative 7 is smaller than whatever x is, because x is somewhere between negative 7 and negative 2. Right? X is one of these numbers in here. Any of those numbers in there will satisfy those two inequalities. Okay, let's look at one where it's not written with the word and. All right. I like to call these conjoined because they're two inequalities written sort of in one, right? So like in one line. The x is in the middle, which is where you want it to be, but it's got a lot of stuff happening to it. So we need to solve it just like we would solve an equation, okay? Whatever we do, to the middle, to get x by itself, we need to do it to the left and to the right side. So you need to do it to all three sections to make it stay true. Okay? So what would be the first thing I would do to try to get x by itself? Add 4 first. So you always start by isolating the term that has the x, in this case the 2x, and then we'll isolate the x. Okay? Then we're going to divide everything by the coefficient of x, which is positive 2. So I'm going to divide everything by 2. And I will get 1 is less than x is less than 7. Now, if they want you to graph it, notice I said if. I don't really know what they're going to ask you to do, but if they ask you to graph it, notice that x is any number between 1 and 7. So that's what you will shade on your number line, is any number between 1 and 7. You'll have an open circle at 1, an open circle at 7, and you'll shade between. X is between 1 and 7. 1 is the low end of what x can be. 7 is the high end. But can it be 1? No, because there's no equal to bar. Can it be 7? No, because there's no equal to bar. Okay, let's do one with or in it, and then we'll move on to the next lesson. I will do one with decimals and fractions. Which means I'm going to need someone with a calculator to make, these aren't hard ones by any means, but I don't want to mess it up since I'm doing this little video here. Actually, don't think it's going to be that bad. Okay? All right, so with or, remember if they have the word or, they're an intersection, which means your final graph and your final solution set will be representative of all of both solutions. Okay? All right, so I'm going to solve this equation just independently and this one independently for p. So here I would need to multiply by 2 on both sides. And I would get that p, and it's a positive 2, so we don't switch our sign. If you multiply or divide by a negative, make sure you flip your inequality sign. So p is greater than negative 6 here. Not if you get a negative answer. If you multiply or divide by a negative in the solving process. Bring down the word or. Here I need to subtract 0.03 from both sides. I think I got this. And I get 0.02p is less than or equal to 0.02. Divide both sides of the equation by positive 0.02. Yeah, I got this. And p is less than or equal to 1. No calculator needed, right? So, as I get ready to graph this, and make sure that the number line answer contains all of both. Here is 0, here is 1. So negative 6 is here. So P is greater than negative 6. I'm going to do it above the line. Let me pick up a different color to do this. So that would be an open circle at negative 6, shaded to the right. P is less than or equal to positive 1. That would be a closed circle on positive 1, shaded to the left. Uh-oh. Now remember, they're marrying each other because they have the word or, so they are doing the union thing, okay? Which means the final answer must be all of both graphs. They have some stuff in common, but that's not what your final answer is. Your final answer is the union of them. Or means union. So my final answer is going to be what? Who sees it? It's pretty crazy. The whole number line. That's right. The whole entire number line. So everything is darkened because when they marry, they got it all, don't they? They had some stuff in common, and then they had what each other didn't have, so to speak. Okay? So the whole number line ends up being graphed. So how would you write the solution set to that? Well, I'm not real sure how it's going to ask you to write it because it doesn't give me an example in the book about how it would ask you to write it. It could be negative infinity to positive infinity. It could be a giant double-legged R to represent all real numbers. It could simply be the words all real numbers. Okay? Does anybody know when that happens? Okay. All right, any questions so far? Okay. All right, so we're moving on to section 3, 9.3. This is going to be absolute value equations. Okay, so this is absolute value in, absolute value equations. Now, let's talk about what is absolute value. Absolute value of a number is defined as how far a number is from 0 on a number line. So the absolute value of 4 is 4. But the absolute value of negative 4 is also 4 because both of those numbers are 4 units from 0. Would everybody agree with that? What's the absolute value of negative 6? 6, because it is 1, 2, 3, 4, 5, 6 units from 0. But likewise, 1, 2, 3, 4, 5, and 6. The absolute value of positive 6 is also 6 units from 0. Okay? So, you can see how absolute values a lot of times have two numbers that can make them true. So if I gave you this equation, the absolute value of x equals 4. Give me two numbers that x could be. Positive 4 and what? Negative 4. Okay? The way that we need to set up our solving process is by creating what I call case 1 and case 2. I don't know if your book calls it that. I don't think it does. But I'm going to give you a couple of steps. Okay? Your first step is going to be to isolate the absolute value, period. Your second step, I'm going to go across with my steps, trying to conserve notebook paper here. Your second step is going to be set up case 1, which will be, I like to say, just drop the bars. The absolute value bars is what I'm talking about. I call them bars because they look like two bars. And set up case 2, which is drop the bars and negate the right side. I just negate the side that has the number on it. We're just going to assume that the right side will always have the number on it. So drop the bars is case 1, drop the bars and negate the side that has the number on it, which is usually the right side. Can absolute value ever equal a negative? Now you've already told me this is positive 4. The answers to this are positive 4 and negative 4. Let me ask you this. Did I follow my 2 cases? Case 1, I'll call it C1. Did I just drop the bars? Rewrite the problem with the bars dropped? Gone? Yes. And my case 2, which I'll call C2, did I drop the bars and negate the numerical side? And is that true? Is the absolute value of both of those 4? Yes. Okay. So, what if I had given you this problem? Absolute value of x equals negative 4. Is that possible? Can the absolute value of a number be a negative? Absolute value's definition is defined, or is how far a number is from 0. It's a distance. Can a distance ever be negative? You can't have a negative distance. Okay? So this is no solution. There are no numbers whose absolute values equal negative 4. Okay? That's the ones you want. You don't have to do anything. You just go, doesn't work. Now you can't assume that until you have done step 1, isolate the absolute value. The absolute value is already isolated in both of these. So I could go straight into the cases. But if there is something added, subtracted, multiplied, or divided outside of the absolute value, you have to undo that stuff first. You got to get it to just be absolute value of some junk equals some stuff. Okay? Before you can solve. Before you can set up your cases. Let's go with another one. I like this one. Absolute value of x equals 0. Why didn't y'all tell me that I didn't spell case right up here? Okay? Case 1 would be drop the bars. The absolute value is already isolated, so x equals 0. Case 2 would be drop the bars and negate. Is there a such thing as a negative 0? No. So there is only one answer to this problem, and it's x equals 0. The only number whose absolute value is 0 is 0. All right, let's do a more difficult one. Absolute value of 3w plus 2 minus 5 equals 12. So this one we have to isolate the absolute value first. So what's done outside of the absolute value? Good. So how do I move that? Very good. Add 5 to both sides. And then I'm left with 3w plus 2 inside the absolute value equals 17. Now I can set up case 1 and case 2. Case 1 is drop the bars. So just rewrite the problem without the bars. Case 2 is drop the bars on the left side and negate the right side. Then you will solve each one of those little equations to find what W is that makes this original equation true. So we're going to subtract 2 from both sides of the equation. 3W equals 15. Divide both sides by 3. So W equals 5. Subtract 2 from both sides. W equals negative 19. Divide by 3. I get W equals negative 19 thirds. So your two solutions are positive 5 and negative 19 thirds. I'm not really sure how they're going to want you to write those two numbers. It looks like solution set form. So it looks like you would write it 5 comma negative 19 thirds inside the braces. Let's do another example of that. Negative 3 times m minus 5, that's absolute value, times the absolute value of m minus 5 equals 7. The first thing we would need to do is isolate the absolute value, so we would do so by dividing both sides by negative 3. And we will get the absolute value of m minus 5 equals 7 divided by negative 3 is negative 7 thirds. You will get into rote, like just where you're just doing it, like a robot, and stop thinking if you're not careful. You must think here. Can the absolute value of some stuff equal a negative? No. So you stop. No solution. But you cannot make that decision until you have isolated the absolute value expression. Okay? Okay, let's do one where there are absolute values on both sides. You still follow the same protocol. These work out kind of funny sometimes, so I'm real careful with them. You just need to be super duper careful with what you're doing. So here we go. Absolute value. I don't want to do that. Let's see. Of 2y minus 4 equals absolute value of 4 minus 2y. You cannot isolate the absolute value here because there's one on each side. So in this case, you do case 1 and case 2. You drop the bars on both sides. And in case 2, you drop the bars on both sides, but you negate the one side. It won't matter which side. I just always stick with the right. And then you solve. So I'm going to add 2y to both sides. 4y. We can go ahead and add this 4 too. 4y equals 8. So y equals 2. Here, you must distribute the negative first. So negative 4 plus 2y. Uh-oh. I told you some of these work out really strange. So when I go to subtract 2y, I get a true statement, don't I? This is supposed to indicate, and I say supposed to because we're going to have to check it, okay? This is supposed to indicate that any number that you put in here will make this true. Remember the all real numbers or the infinitely many solutions when we were doing systems of equations? It's the same kind of concept. If you get a true statement, it's supposed to be that all of them work. This one says only 2 will work, okay? What we need to do is we need to check. I'm not going to check 2 because what I'm going to do is I'm going to check any other number, and if any other number works, just a random number, then 2 is going to work because 2 would be part of all real numbers, wouldn't it? Does that make sense? That reasoning makes sense? Okay, so let's just pick a number because to me this means all real numbers work. Our solutions. Let's say our solutions. And then let's put a question mark right there like, we need to check it. Okay, so let's just pick a number. Let's not pick like 0 or anything. Let's pick 5. Is everybody good with that? I'm going to test 5. Test y equals 5 is what I should say. So the absolute value of 2 times 5 minus 4, does that equal the absolute value of 4 minus 2 times 5? 10 minus 4 is 6. Does the absolute value of 6 equal 4 minus 10 is negative 6? Do they equal each other? Does the absolute value of positive 6 equal the absolute value of negative 6? Yes. So this does check out, and your solutions are all real numbers. I don't know how they're going to want you to notate that, but you could pick any number you wanted to and put it in this original equation. You have to test them. Always check in the original. And it's going to work every time. Okay? Very strange, I know.
How do we know on case 2? If we added 4 to both sides, and we have 0 equals 0.
Well, it's still a true statement. Variables go away and you have a true statement. If all your variables cancel out and you're left with a number equals itself, that's true, which indicates all real numbers should make the original equation work. Okay? Any other questions? Okay.